We've been working with sines and cosines in right triangle trigonometry, but we can also use sines and cosines in non-right angle triangles, and we can extend those definitions to obtuse triangles. And so we can use the law of sines, and we're going to start with that, and then we'll go to the law of cosines a little bit later. We can use the law of sines to solve a triangle if we know the measures of two angles and any side. So we can do that with angle, angle side, or angle side, angle. And we're first going to look at angle, angle side. But let's go over the law of sines itself. Now we can establish ratios between certain angles and the sides opposite those angles. So for instance, we can have a ratio between angle A and side A, and then we can establish a ratio between angle B and side B, and we can also establish a ratio between angle C and side C. And these ratios are going to be proportional. In other words, the sine of A over side A is equal to the sine of B over side B, and that's also going to be equal to the sine of C over side C. And so if we know a couple of angles and a side, then we're able to solve a triangle. So what do you say we try one? Here we go. All right, so we got a triangle here, and we've got two angle measures, 60 and 78. And we know one side measure, side BC, or the side opposite A. Here's angle A at 78 degrees, and the side opposite of it is 8. And we know this angle B, 60 degrees, and we're asked to solve for the side opposite of it, which is labeled X, or segment AC. Well, we can use the law of sines to do this. And so let's set up our proportion. And first we'll set up the ratio of sine A to the side opposite. So we got the sine of A over 8, and that's going to equal the sine, let me change that A to 78, sine of 78 over 8, and that's going to equal the sine of 60 over X. And we can do a little cross multiplication, and then we got X times the sine of 78 equals 8 times the sine of 60. And then if we divide both sides by the sine of 78, then X, the side measure we're trying to find, is going to be equal to 8 times the sine of 60 divided by the sine of 78. Now, I believe we're supposed to round these to the nearest tenth. Yes, we are. All right, well, let me get my calculator out. So let's start with 8 times the sine of 60. We're using the law of sines. And now we're going to divide that by the sine of 78. And that comes to 7.08298. We're going to round to the nearest tenth. And so X is approximately equal to 7.1. So we found this side right here using the law of sines. We had angle, angle, side, and we could use that to find the missing side measure. Shall we do another? I think we should. By all means, please do. All right, what do we got this time? Okay. Well, I see here angle S is 54, and I can establish a ratio with it with the side opposite, which we have a measure of 8. QR is equal to 8. I've got an angle measure here of 37, but I don't have anything, and I'm not asked to solve for anything. I don't have the measure of angle R, but you know what? I can find it very quickly because I got two other angles. So let's find the measure of angle R first so we can get on with finding X, the side opposite R. So I got 180 degrees in a triangle. We know that one angle is 54. We know that the second angle is 37. We're trying to find for the measure of R. So 180 minus 54 minus 37. So R is an 89 degree angle. Oh, and now that we've done that, let's set up our ratios and find for X. So I've got the sine of 54 over 8, and that's going to equal the sine of 89 over X. And again, we're going to do a little cross multiplication. We got X times the sine of 54 equals 8 times the sine of 89. Let's divide both sides by the sine of 54. So X, isolate the X. X is equal to 8 times the sine of 89 divided by the sine of 54. And let's see what X is approximately equal to. All right, let's see. 8 times the sine of 89 boom, and let's divide that by the sine of 54. 9.88704. We're going to round that to the nearest tenth, 9.88, and it's approximately equal to 9.9. The law of sines. Now we're going to look at a couple of more in a moment. Law of sines, this time where we've got angle, side, angle.